All right, so we're going to find the equation of the tangent line to r equals sine 4 theta cosine theta when when theta equals pi over 6. So first step is what? Okay, x and y, exactly. So if we got sine 4 theta cosine theta, we got x is equal to r cosine theta, so that'd be sine 4 theta, and if we're multiplying that by cosine theta, that's going to be cosine squared theta. That's going to be fun to take the derivative of. And the y is going to be even more fun, it looks like. Y equals r times sine theta, so that's sine 4 theta cosine theta sine theta. It looks even less pleasant. And we're interested in the tangent line at pi over 6. So first thing we should do is just plug in pi over 6 to both of those to figure out the x values. So we got x equals the sine of 4 pi over 6, which is the same as the sine of 2 pi over 3. What's the sine of 2 pi over 3? Yeah, root 3 over 2. And cosine squared of pi over 6. So cosine of pi over 6 is also root 3 over 2, right? And so we've got that squared. So we got root 3 over 2 times root 3 over 2 squared, which would be root 3 over 2 cubed, or what would that end up being? 3 root 3 over 8. Everybody agree with that? Hopefully so. And for our y value, plugging in pi over 6, we're looking at the sine of 4 pi over 6, which is still sine of 2 pi over 3, so that's still the root 3 over 2. Then we got cosine of pi over 6, which is another root 3 over 2. And then we got sine of pi over 6, which is a half. So this one just becomes 3/8. Everybody good there? Okay. Then we're going to have to find dy dx by doing dy d theta over dx d theta. Now our y value's got 3 terms in it, which is going to make our product rule a little bit more of a pain. Anybody want to simplify that down a little bit so that it's only got 2 terms in it? Anybody see a good way to do that? Just to make the derivative taking a bit easier. How can we simplify that y down? Yeah, exactly, Ryan. We're going to use double angle identity. So we know that 2 sine theta cosine theta is sine 2 theta, right? Well, we just have sine theta cosine theta, so divide them both by 2, that'd be 1/2 sine 2 theta. So we'll say that y is also equal to 1/2 sine 4 theta sine 2 theta. It's still going to require us to use a little bit of the chain rule within the product rule, but at least it's not the product rule within the product rule, which gets a little bit messy. So I think that might be a little bit easier. So we'll do dy dx is equal to, and then we're going to take the derivative of our y with respect to theta. So we'll treat the 1/2 sine 4 theta as if it's that's the first term. So I have 1/2 sine 4 theta times the derivative of sine 2 theta, which is 2 cosine 2 theta, plus the sine 2 theta times the derivative of 1/2 sine 4 theta, which should be 2 cosine 4 theta. And we'll put all of that over the derivative of x with respect to theta, which will be sine 4 theta. Derivative of cosine squared theta should be 2 cosine theta times the derivative of cosine theta, which is negative sine theta. And then derivative of sine 4 theta should be 4 cosine 4 theta times cosine squared theta. Everybody good with the derivative there? Okay, and so we'll just plug it in. We'll evaluate dy dx at theta equals pi over 6. So we got sine of 4 theta, so sine of 4 pi over 6. We know that's still root 3 over 2. So we've got 1/2. We got root 3 over 2. Looking for the cosine. We'll go our 2 first. We're looking for the cosine of pi over 3. Cosine of pi over 3 should be 1/2. And then plus the sine of pi over 3 when we double that angle, which should be root 3 over 2. And times 2, and times the cosine of 2 pi over 3. What's the cosine of 2 pi over 3? Okay, nobody's answering, so we'll just put it in. It should be -1/2. Yeah. Second quadrant. Reference angle of pi over 3. And over in the denominator, we got -2. And then we got our sine of 4 theta again is root 3 over 2. Our cosine of pi over 6 is root 3 over 2. Our sine of pi over 6 is 1/2. For our cosine of 2 pi over 3 is again -1/2. And then cosine squared of theta, so cosine of pi over 6 is root 3 over 2. We square root 3 over 2 should give us 3/4. Everybody agree with all of those numbers in there? A lot of little trig values. Anybody have any issues with those? All right, so the 2.5 will cancel, so we got root 3 over 4 here. And then here, the 2.5 will cancel, so we got minus root 3 over 2. And the denominator, 2.5 here will cancel. Root 3 times root 3 is 3. So we got 3 over 2 times 1/2 is 3 over 4 with the negative. So we got -3/4. And over here, the 4 and the 4 will cancel, and we got minus 3/2. Everybody good there? I'll take that as a yes, since no one's saying anything. If we get a common denominator here of 4, multiply this by 2 over 2. Root 3 minus 2 root 3 should be negative root 3 over 4. And in the denominator there, if we get a common denominator here, that's going to be can you guys not see? Is that why you're just ignoring me? All right, I don't know what I can do to fix that. Let's see here. Yeah, I don't know. I mean, if you guys want to try and jump out and jump back in, you can try that. Is it fine for some people, or okay? Yeah, some people are all right. So if you're having an issue, just we'll wait a minute and jump back out and jump back in. All right, I think we got everybody back. You guys all hear me all right? Everybody back in? Everybody good? Everybody can hear me or no? Not sure what happened. I just got kicked out of it, but now I'm back. You guys can hear me okay or no? Now a bunch of people are getting kicked out. This is going really well. I'm going to stop this recording now. We'll pick this up in a minute.